All right, starting lesson 8.1, find angle measures in polygons. All right, so we know the sum of the interior angles of a triangle is 180 degrees. Now you can determine the sum of the interior angle measures of any polygon by dividing it into triangles. All right, so here I have this chart below, working with a triangle, or we could also call a triangle a threegon because it has three sides. So it has three sides, and the number of triangles in a triangle is 1, and all the angles we know add up to 180 degrees. Okay, so now for a quadrilateral, I'm going to start from any point, and from here I need to draw a line to any non-adjacent vertex. All right, these would be adjacent vertexes. Okay, I want a non-adjacent vertex, which would be right here. All right, so now that splits the quadrilateral into two triangles. See, 1, 2. All right, so how many sides does a quadrilateral have? It has 4 sides. And how many triangles were we able to fit into this quadrilateral? 2. Okay, and what do all the angles of a quadrilateral add up to? Well, you just take 180 and you multiply by 2, which gives you 360. All right, now let's go to a fivegon or a pentagon. All right, now notice that this is called a regular polygon. Now what makes a polygon regular is that all the sides have the same length and all the angles have the same measure. Okay, now with this pentagon, we're going to start off from one vertex and draw lines or segments to non-adjacent vertices. There's one and there's another one. All right, so I could fit 1, 2, 3 triangles in this pentagon. How many sides does a pentagon have? 5. How many triangles was I able to fit in that pentagon? 3. All right, so since there are 3 triangles, I take 3 and I multiply by 180, and I get 540. All right, let's move on to the hexagon. Same deal. I'm going to start at any vertex, right, and draw segments to the non-adjacent vertices. How many triangles do I have? 1, 2, 3, 4. How many sides does a hexagon have? 6. How many triangles was I able to fit inside that hexagon? 4. All right, so I'm going to do 4 times 180, which is 720. All right, that's what all the angles of a hexagon add up to. If you add up all of these angle measures, this one, this one, this one, this one, and this one, they would all add up to 720, okay? So then it says n-gon, all right? That just means there could be any number of sides. So let's look at the information we have here in this chart. Do you notice a pattern? All right, 3 to 1, 4 to 2, 5 to 3, 6 to 4. If I take the number of sides and I subtract 2, that gives me the number of triangles. Number of sides, subtract 2, number of triangles. Number of sides, subtract 2, number of triangles. Number of sides, subtract 2, the number of triangles. Okay, so if I have n sides, how many triangles are going to fit in that figure then? Well, it's the number of sides minus 2. Okay, and what will the sum of all the angle measures be? Well, it's going to be n minus 2 times 180. All right, and there's your formula. So if I have a polygon with n sides, to figure out the sum of all the sides, I just take n minus 2 and I multiply by 180. So we have this formula now to work with, the polygon interior angle sum theorem. The sum of the measures of the interior angles of an n-gon is n minus 2 times 180. All right, if you don't understand 100% how we came up with that formula, please make sure to ask for help. All right, going to example 1, let's apply this formula now. Find the value of x. Well, what type of figure do I have here? This is a quadrilateral, so it has 4 sides. So in this case, n is equal to 4. So I take 4, I plug it into the formula, and I get 2 times 180, which is 360. Okay, so all of these angles here, every one of these angles, adds up to 360. Alright, so I'm going to take all the angles, x plus 108 plus 121 plus 59, and I know that they all add up to 360. Alright, let's add up these angle measures. Alright, now I have 108 plus 121 plus 59. That's equal to 288. Subtract that over. Alright, and so x is equal to 72. Done. Alright, let's do the next example. DEA. Here I have DEA. So what do all of these angles add up to? Well, using the formula, how many sides do I have? I have 5 sides. I'm going to subtract 2 and then multiply by 180. That gives me 3 times 180, which is 540. So all of these angles should add up to 540. So I have measurement of angle DEA plus 114 plus 105 plus 102 plus 135 is equal to 540. Alright, so I'm going to add these angle measurements up. 114 plus 105 plus 102 plus 135, that's equal to 456. I'm going to subtract 456, and I get measurement angle DEA is equal to 84 degrees. Done. All right, finding each polygon interior angle measure. Okay, now to find each interior angle of a polygon, it has to be a regular polygon, meaning all the angles are the same. So what you do is you take our formula for what all the angles add up to. Okay, now how do you find each angle? Well, however many sides there are, that's how many angles there are. So you take this formula and you simply divide it by n, and now you have the measurement of each angle. Alright, so let's apply this formula in example 2. Determine the measure of each interior angle of a regular pentagon. Alright, pentagon means n is equal to 5. So plugging n into our formula, so we have 3 times 180 over 5, we have 540 over 5, and that's equal to 108. So each angle of a pentagon measures 108 degrees. All right, for part B, the measure of each interior angle of a regular polygon is 120 degrees. Interior is a keyword, regular is a keyword. All right, is 120 degrees. How many sides does the polygon have? What is the name of the polygon? All right, so this formula here tells you what each angle measures. That's what they told me here. So I know I take this formula and I set it equal to 120 degrees. I need to figure out what n is now. All right, how am I going to do that? Well, I have this fraction here. How do you get rid of it? I'm going to multiply by n on both sides. That cancels out. So I have n minus 2 times 180 is equal to 120 n. Okay, I'm going to distribute this here. So I have 180n minus 360 equals 120n. Then I subtract 180n. So I have negative 360 is equal to negative 60n. Divide by negative 60, and n is equal to 6. Six sides means I have a hexagon. Done. All right, the polygon exterior angle sum theorem. Okay, before we were working with interior angles, now we're working with exterior angles, angles on the outside. Okay, and the nice thing about exterior angle problems is this. The sum of all the exterior angles, they always add up to 360. All right, not much brain work involved there. All right, so if I take measurement angle 1 plus measurement angle 2 plus measurement angle 3 plus measurement angle 4 plus measurement angle 5, in this example with the pentagon, all the angles will add up to 360. And that's with any polygon. All right, so for example 3, find the value of the variable. What am I looking at here? What types of angles? These are all exterior angles. So I have 2y plus 2y plus y is equal to what? You don't have to think much about it. It's always the same number, 360. All right, so now I have 6y is equal to 360. Divide by 6, and y is equal to 60. Done. All right, for the next one, the figure below is a regular octagon. All right, since it's regular, I know all the interior angles are the same, and that means all of the exterior angles are the same. All right, so these are all x then. The key word here was regular. All right, that means that all the angles are the same, interior as well as exterior. All right, so how many exterior angles do I have here? I have 8. So x plus x plus x plus x, 8 times. So it's going to be 8x is equal to what? What do all of the angles always add up to? When you're talking about exterior angles, they always add up to 360. So I take 360, I divide by 8, and I get 45. Done. All right, the last formula for this lesson, find each polygon exterior angle measure. Okay, well, you know that all of the exterior angles together, the sum, is 360. Now this is very similar to what we did in the first formula, where we wanted to find each interior angle. Okay, well, how do you find each exterior angle? You just divide by the number of sides or angles that you have, which is n. All right, that's all there is to it. So example 4, find the measure of each exterior angle of a regular decagon. How many sides does a decagon have? It has 10. So it says to find the measure of each exterior angle. I know that all of the angles add up to 360. If I want each, I have to divide by n. Okay, and in this case, n is equal to 10. So each angle is equal to 36 degrees. And that's the exterior angle. All right, for part B, the measure of an exterior angle of a regular n-gon is 72 degrees. How many sides does the polygon have? What is the name of the polygon? Okay, they tell me that each exterior angle is 72 degrees. That's what this formula is supposed to give me. So take this formula and set it equal to 72. Now I need to get n by itself. So multiply by n on both sides. 360 is equal to 72n. Divide by 72. And n is equal to 5. So if there are 5 sides, that means the polygon is a pentagon. All right, these problems are really simple once you get the hang of it. All right, so there are 4 formulas. Make sure you understand when or in what situation to apply each particular formula. If you have any questions, if you're not sure about something, please make sure to ask for help. Begin the assignment now.